I've started this on the 25th of October, and it's only that today I've got it right. Well, on the good side, it's only gonna take you about 30 minutes. Hey guys, in October I have received Super6C, which is this incredible cluster board that you can use with Compute Module 4. And I was eager to give it a go, and while the board was working with micro SD cards, my goal was to set up NVMe boot. And oh boy, I was in trouble and I didn't know it. And don't worry, if you just want to set it up and you're not interested in the story, then there are timestamps available for you and chapters, so take advantage of it. I'm gonna have separate guides for doing it on Windows, separate guides for doing it on Linux, and a completely different chapter that will cover cloning OS onto the NVMe drive. But if you are sticking around, you're gonna learn something quite important. I've been through hell with this because I've absolutely tried everything there was. I've scoured the internet, followed a couple of guides, and gathered every single piece of information I could to actually get it working. In the end, it turns out that it was the fault of my NVMe hard drives that I've picked from Integral. I don't know what exactly is wrong with them. I've reached out to Integral to find out why these are so different from the Kingston one that, well, came as a Hail Mary and saved pretty much everything. But I'm still waiting for the reply for them, so hopefully I'll get a little bit more information soon. So, if you're trying to set up boot from NVMe and you've got one of those screens, so this one happens with a 60 seconds delay when I'm just hardware power cycle it, and this one happens when I'm trying to either power it down or reboot it using the software commands and it hangs and never recovers, then check your NVMe drive. In the description of this video I'm going to also include the ones that worked for me, so you don't end up buying something incompatible, and I'm also gonna include the one that didn't work, just so you'd know what to avoid. By the way, huge thanks to DeskPi team, which was actively supporting me through the entire ordeal. They also sent me the second Super6C board so I could investigate and check if the board was at fault, so they were absolutely wonderful and I could recommend the DeskPi without hesitation. So with that said, let's talk about Compute Module 4 boot from NVMe. Now it uses NVMe, and in theory that should be a speed bump to your solid state drives because it latches on to the PCI Express instead of the USB bus, like it's the case with Raspberry Pi 4 and USB port. But in practice you're probably not going to see that much of a difference. However, yeah, every kilobyte per second counts, so here we are. Playing with Compute Module 4, it's a little bit difficult from the start, because first you'll have to figure out which Compute Module you should get, because there are 32 different configurations. A typical Compute Module model number starts with CM4 followed by some, well, random numbers. Well, these are not random numbers, these are actually configuration specification for particular SKU. And if you want to know what they mean, this picture should explain that, and also in the linked article to this very video you'll find complete breakdown of these. But for the purpose of this video you are only interested in two factors, that half of those 32 SKUs are Compute Module Lite and the other one that are just regular Compute Module. So what's the difference between CM4 and CM4 Lite? Well, Lite ones doesn't have eMMC storage, which means you will definitely need a microSD card or whatever your carrier board supports. And why does it matter? Why am I talking about this? Because depending on which Compute Module you've got, well, the setup instructions is going to be slightly difficult. There is a last piece of information that you also need in order to successfully update the firmware of the EEPROM. Now, you will need a separate computer. Unlike Raspberry Pi 4, which you can self-update the EEPROM and then boot to, for example, boot from USB or network boot, this is currently not possible with the CM4 modules. You can either use a Windows computer or you can use another Raspberry Pi 4 or 3, or just a Linux computer. Let's start with a scenario in which you are lucky. If you're lucky, your compute module actually comes with a recent firmware to the bootloader. That means you actually don't have to configure anything, providing that A, well, your CM4 has that recent firmware, and B, you're not using CM4 regular module. That only applies to the CM4 Lite because they don't come with eMMC. And you are probably wondering why. Now, eMMC module on your CM4 boards is basically treated like an SD card. And while SD card can be easily removed, well, eMMC module, you can try, but I wouldn't recommend you, especially with how scarce the CM4 modules are. So if you have a recent firmware and a CM4 Lite board, all you have to do is write your Raspberry Pi OS on NVMe drive. However, it's not as simple because you're gonna probably need something like this. If you ever used M.2 drives, you'll quickly notice that on a computer they show up as regular drives, not as USB media. And that is no good because Raspberry Pi Imager won't let you flash Raspberry Pi OS on the regular drive. It needs to be a bootable media, well, a USB stick or something similar. Now, yes, there are probably different versions of flashes that you could use and designated there at different letters, but for the purpose of this tutorial, we're going to be using Raspberry Pi Imager. So if you want to bypass it, I would strongly recommend you to spend a little bit, like £17 on Amazon, and get one of these. This is NVMe to USB adapter. It means that you can use either SATA or NVMe drive, plug it in, connect it to your computer, and it will show up as your regular USB stick. It means that Raspberry Pi Imager will quickly recognize it and allow you to flash it with software. Yes, you are throwing money at the problem, but trust me, after weeks of trying different things, I don't mind actually spending extra for the peace of mind. The method simply works. Once you flash it, simply just plug in your M.2 drive, remove the SD card, and you're ready to go, providing you have a current firmware. But if you don't have the current firmware, or you have a board with a eMMC, then you'll have to go through one of these tutorials, and we're going to start with Windows. To get started, we need a Raspberry Pi operating system running on Compute Module 4. You probably have already a carrier board, so you know how to use that, but if you have a Lite module, this is easy. Just use a micro SD card, flash it with the image of your choice, plug it in, and you are ready to go to the next step. Now, if you have the Raspberry Pi CM4 modules with eMMC, the case is slightly more complex. To take care of that, you'll have to download RPBoot installer for Windows. It's available on the Raspberry Pi website. Also, links going to be included in the article attached to this video, so go check it out. Now, once you have this downloaded, check out your carrier board. I'm using Super6C, my carrier board, and it has a pins that I can join with a jumper. Now, one of those says RPBoot, and this is the one that will put my Raspberry Pi Compute Module 4 into a boot mode, which means it's going to be also available as a USB storage to my computer when I connect it via micro USB cable. All I have to do is start application on my Windows device, then put a jumper on the carrier board on a J2 junction to enable the mass storage mode, and plug it to my computer. Then power cycle the Compute Module 4, and my Windows machine is going to see it as a USB stick. That way, when I launch my Raspberry Pi Imager, I'll be able to select it and actually flash my operating system. So do that. Our next step is actually update the EEPROM bootloader. So let's do that. That utility that you just downloaded on Windows will also do that for you, which is handy. Well, first option, we can cheat. You can simply download the zipped folder that I've included on my website, and it will contain everything. Updated firmware for an EEPROM, reconfigured boot, config file, so you could get started. All you have to do really is just download that zip and unpack it into your recovery location where the Raspberry Pi utility is installed. Overwrite all the files and you'll be ready to flash your Raspberry Pi Compute Module 4. I modified the boot order already, so NVMe starts as first, and I retain the SD card or eMMC boot as the second, just as a backup option. If you want to amend this boot order, just access the boot config file and make necessary changes. Go back one directory to a folder in which you see rpboot, and then shift and right click into an empty place to bring PowerShell in this specific folder. Command line works as well. Now, in order to send all those files to a Raspberry Pi, jump around the J2 junction to put it in the rpboot mode, connect it to your PC, and then power cycle. Just make sure you don't have anything else connected to your PC, because sometimes it might actually try to send these files to something else. In my case, my mouse dongle was causing issues. Start rpboot.exe with the deflag and the recovery, and that will start the process of flashing. As soon as the Raspberry Pi Compute Module 4 is power cycled and connected via USB cable, it will take only a couple of moments to complete the flash. And there you have it. You have already one of the latest November firmware, and you'll be able to use NVMe straight away. But if you don't want to cheat, okay, I'll show you how to do it the proper way and how I got the files to begin with. Let's start with actually booting Raspberry Pi OS again and accessing it, because this is where we have to go. We're going to need Git and a list of utilities to actually make it happen. Now, once you download it, then second thing, we have to download the USB boot application from the GitHub too. Follow that and then build entire application on your Raspberry Pi, and you'll be ready to update your firmware. Go to the USB boot recovery and then remove the existing firmware, which is Pi EEPROM original bin. Download the latest stable firmware and update your EEPROM. Now, if you want to check if you have the latest firmware, then go to the link included in my article or to the repository of Raspberry Pi, and it will show you what is the current version. That way, just change the URL and download the latest version that you are interested in, and then perform the update Pi EEPROM. At this stage, you probably want to edit the boot order, because the default boot order won't have NVMe as a first device. In the boot order line, everything is being read from right to left, so it's all the way around. And you'll notice that it starts with 1, and it should really start with 6, because 6 is responsible for NVMe. If you want to know what other numbers mean, then look up this table. It will tell you everything about each device and how to utilize that boot order. Now, save that, and you have a bunch of files that you need to download on your Windows PC. Now, I was lazy. I already have a Notepad Plus with SFTP plugin, which allows me to actually SSH into my Raspberry Pi and download files this way. So I've used it. I've zipped the files first, and then I've selected the file and downloaded it onto my computer. You can use obviously any other way of transferring that recovery folder onto your computer, and those are the files that I supplied you in my first method, the cheating one. At this point, all you have to do is just unpack the zip, drop the files and replace the ones that are in recovery folder in the Raspberry Pi utility, and you are ready to go. And now let's do it all the same with the Linux computer instead. Oh, Raspberry Pi 4, which is waiting here. So if you just watch the section about the Windows, feel free to skip to the cloning part, which is at this timestamp. Grab your Raspberry Pi that you're going to use to flash your CM4 board with and access it. We're going to need to install Git and a couple of supporting libraries. Once we've got that, then we're also going to need rpboot utility available from Raspberry Pi repository. Clone that repository, access it, and build it. It's going to build locally, so you'll have to access that particular folder in order to use it, but that's fine. We're only going to use it once, right? Or maybe twice, if you really fancy. Now, in the installation folder, access recovery folder and remove the existing firmware, which is Pi-ROM original bin. We're not going to use that, we need a new one. Now, in order to get that, you probably want to navigate to a Raspberry Pi repository and check if there is a latest firmware for your EEPROM. I've included firmware from the stable release from November, which works, but if you want to check if there is anything new, there is a link in the description of this video to my article that covers this a little bit in more details, including all the commands. If you want to get URL for that new firmware, simply access the firmware, right click on it and copy URL link. That will be the link that you'll have to paste after the curl command. To update all the files, simply run update pi EEPROM sh and it'll do that for you. At this point you probably want to modify your boot order. So in the same folder you'll find boot config file that you'll need to edit. The line responsible for boot order, well, you read that from right to left, which is a bit bizarre, but you'll notice that it by default ends on 1 and it should end on 6. So you can grab that 6 and move it over to the last position or first position, depending on how you're reading it. And that is your NVMe drive. If you want to know a little bit more details about the boot order and which devices which, then head to the article linked to this video and I'll explain everything in there for you. But for the purpose of this video, just make sure your boot order looks like mine and we can skip to the next part. When you are happy with your changes, just go up until you see rp boot script, and this is the one we're going to use to actually flash EEPROM. The command is rpboot followed by the D flag and recovery, because that's the folder we're going to push to your EEPROM. Now it's time to connect a USB cable and put the jumper on J2 junction on your CM4 carrier board. As soon as the board reboots, you will see that it is receiving a new firmware. By the way, if you have a HDMI display connected to your CM4 board, you'll see that being completed with a nice green screen. If you at this stage have any problems, just make sure you don't have any other USB devices connected to your Raspberry Pi or Linux computer. On my Windows computer I had problems with my USB dongle from the mouse, so it's something good to keep in mind. When the process is complete, remove the jumper and power cycle your CM4 board again. Now you can SSH to it and confirm that your firmware is up to date. Just simply run this command. Cloning Raspberry Pi OS to NVMe was a bit of a pain too, mostly because the tools I'm used to using for Raspberry Pi 4 are also broken. At first I opted out for rpclone, which is something I recommend for Raspberry Pi 4 devices to clone your partitions to USB boot, and that works flawlessly, but as the libraries weren't updated in 4 years, NVMe isn't quite supported. There is a PR release that supposedly fixes it, but in my experience I had horrible time going through the process. I've included more details in my write-up, so go and check it out. I'm not going to cover in this video because we're going to use DD instead, because it's quicker, simpler, and it just works every time. Power off your CM4 module and install NVMe drive to your carrier board. Now remember, get the good NVMe drives, not like me, because you're gonna end up doing this for forever. Anyway, once it's there, just access the compute module via SSH again, and you can use fdisk to format the drive and create a partition. To have a quick lookup table of your drive, use lsblk to see it just before you use DD. It's gonna come in handy. Your input file is going to be either your micro SD card or your eMMC storage, depending on what kind of compute module you've got. And your output file is going to be obviously that NVMe drive. The whole process is going to take a couple of minutes. Now, the bigger your SD card or eMMC size, the longer it takes, because it copies basically bit by bit. Now, after a couple of minutes, you should see that everything has been copied, and this is the point where you can do a couple of things. If you're using CM4, then you can simply power it off, remove the micro SD card, and run your the compute module again. You should be able to access it without any problems. But if this is a compute module with eMMC storage, you can also plug it back as a storage device and wipe it so you could get that space back and use it for something else. So that choice is yours. It's perfectly fine to leave the operating system on it as well, because your boot order is already changed and it should boot from NVMe first. And that's pretty much it. I am slightly disappointed with the amount of time it took me to realize that I have problems with all three NVMe drive that I bought, so yeah, I don't think I'm gonna get those 20 to 30 hours back, but if that makes the whole process much clearer to you, then it was definitely worth it. At this point, if you are interested what am I going to do with this 12 CM4 cluster in 2 boards, then I don't have a posting schedule, so if you want to find out, YouTube gives you brilliant tools to get notifications when the new content is out. Use all of that, I'm pretty sure you know how to do it. As for now, I do have a couple of social media accounts that you should probably follow if you want to start a conversation with me, and thanks so much for watching. See you next time. Take care. Bye.